Does the wealth of a country influence its citizens' life expectancy? In other words, do you live longer in countries that have more money? What we will do to analyze this situation is use data and the Desmos graphing calculator to help us interpret the data and answer these larger questions. By the way, this data was sourced from Our World in Data, and that website is linked there below. So I'm going to first go to the data itself. And you see here each country listed, its GDP per capita in dollars, and its life expectancy at birth in years. I also had population data as well, but there's a total of 150 some countries listed here. What I'm going to do is copy these columns for GDP and life expectancy and paste that into a Desmos graphing calculator. So here in the graphing calculator, I just simply paste and all of the data is pasted for me. Notice there's so many rows that it even condenses it here. So first analyze the shape of this data. What type of function do you think will best model this data? Some other questions to consider are what trends do you notice in this data? How would you describe the relationship between the GDP and the life expectancy? So, describing that relationship, explaining trends, and determining the type of function that may best model the data is easier to do given the graph of the data. And if you watch my cursor here, it's as if it makes a steep increase and then it's leveling off as we continue to increase the x value. This is just like the logarithmic function. So what we will do next is use the calculator's regression tools to calculate a logarithmic model for this data. We'll also compare the residual plots and we'll record that model that best fits the data and sketch here as well. You can simply take a screenshot to include those things here. So back to the calculator, if I go to the next line and type y1 tilde, and here I'm going to type in a transform version of the logarithmic function. So I need to transform it by multiplying it by a. And I also need to transform the inside of the function by multiplying it by b. And then adding parameters c inside and outside of the function. Oh, and one more thing, that should be x sub 1. So just type the 1. And notice that A, B, C, and D are arbitrary. They could have been other letters. But regardless, it found those parameters for me, those values in that regression. And I have this nice logarithmic curve to model that data. One other feature we're asked to look at are the residuals. So you could just click plot to see those residuals. And notice that an additional column has been added to the table. And you don't see the residuals because they're actually much smaller compared to the y values themselves. So I have to click and drag the entire graph to move down here to see the residuals. They are fairly scattered about the x-axis, so that tells me that this may be a good model. But honestly, one thing I don't like seeing in these residuals is it has this funnel effect. So maybe perhaps there's an even better model that of a function we haven't studied yet. And the last question asks if there's a new country that has a GDP of $48,100, what would you predict its life expectancy to be? And to determine that with the actual graph, I can just click on this black curve and drag until I get close to 4810. I see the life expectancy is close to about 80 years old.